Going on, Tommy? What's happening, Adam? I'm having so much fun experimenting with these coils that I had to go back on, show you guys some cool stuff. So what do you think here? I'm just feeling out the coils, trying different variations. I have all these right here that I'll be hooking up tomorrow. I ran out of cores. So all these cores now are fixed. And I have them spaced out really good. I got them spaced out like I didn't use this washer, but I used a bigger washer. So, and you got those spaced out as well. Pretty cool looking, huh? Leave your comments. So, these are the inductor. These are the inductor. We're starting right now as the centers are going to be the inductor as the starter. So right now, we're not set up how we're supposed to be set up. And in order to get the pole started in this array, remember there's going to be a rail of a lot more coils, you know, coming down the line. There's going to be actually 7 of them. And yeah. So let's go ahead and turn it up just a little bit. We'll put about 6 volts in it. And we can see that I have all the bottoms here set up to be south. Now these are all magnetic induction coming from the center inductor. Right now, the center is the inductor. When I get this all set up, that'll be turned off. The outsides will oscillate in a row and start off a cycle. Then the inside bigger coils will be the pickup, and that's where we're going to put the load. The load. Free energy. Here you come, baby. So over on this side, I have everything is a north. Okay. And we got some good magnetic strength, especially in the center ones. Hard to pull off there. The outside's got the magnetic strength as well. Same as over here. Got magnetic strength. And nothing's touching these, okay? So what I find to be pretty cool about this setup and the experiments is that this iron core is being filled with magnets. It's not touching, and it's filled up. It's charged up right now. There's a bunch of electrons in these guys right now. Let's go ahead and do a cool test. We're going to do an experiment right now. We'll disconnect that. You're going to like this. You ready for this one, Adam and Tommy? Let's go ahead and put the lights off a little bit. And here we go. You're gonna like this. Why are you gonna like this? Notice I got LEDs on each individual one. Okay? Let's go ahead and now these inductive coils look at the LEDs all lighting up. That's the back EMF, guys. I'm only calling it the back EMF because it is the back EMF. It's the charge that's going inside these cores. When this is built up, it puts a pressure inside each core, not even touching. Inside each core, there's an electron pressure that goes in there. And when this pressure is deleted, the pressure that's in here can't escape back out, so it runs out the coil. You guys get that? Let's look at that again. So this is the back EMF, all 6 are flashing. Now, it wasn't easy to get this set up the way it is right now. I had to go through a good array of changing to get things how I want it. For instance, let's go ahead and put some light on here. For instance, it's very important that each coil is wound in a certain direction. Let me tell you why. Now, when I take, to figure out just this array the way it sits, I took this first coil. Yes, Adam, you got that. Polarity inversion issues. So basically, you have to set the polarities how you want them. And that's what I wanted. I wanted this, in order for this is what I'm working on. This is the inductor for the start of the process of the half cycle. Consider this a cycle once I get 7 rows up. The half cycle is that each one of these are going to ping, and there's a half cycle. The second part of that half cycle is the outside is doing the pinging. It's ping, 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 ping. While it's pinging, the magnetic field flux is changing through the center inductor area. Once that happens, then we start to have current. As you put a resistance on here, current will flow the direction that I'm sending it all in downstream. So in order to start the process of this whole thinking of downstream, I had to start with the first individual coil. And basically, I want it south to be in the bottom here, and I want north to be right here. So this here, naturally, the way when it gets fired up from outside source power, it automatically turns to north here and south here. So I know naturally it's set up already. Now, secondly, because there's always a backstory to everything. There's always a back EMF when you're dealing with coils. So you got the north here, you got the south here. Now, on this next coil, now I set that one. On this next coil, it needs to be fired up the same way, because what you have to do is when you fire this up now, you have to make sure that that one stays the north, because if this is not shooting the right polarity, well, let's get into how this starts the process. So let's call this the one spark theory, okay? And this is what I'm calling it, the one spark theory. This is, you start off a spark in these coils, and the back EMF through certain lining up what wires go where and resistance, the back EMF will continue to the next level. Then the next level, then the next level, the next level, the next level. It's going to be a, if I can explain it in any way, it's going to be a sine, okay? It's a resistance. So it's going to have a climb. It's going to have a climb and then a decrease. Incline in pressure, decrease in pressure. It's going to be a collapsing kaleidoscope is a good way to look at it, but the main thing is that it becomes a sine. The sign that it'll have is this will be your increase, and this will be your neutral, and this will be your decrease. and basically we're completing a half cycle to be a sine. The sine is the powered up version, and then you turn the power off. We're going to be able to turn the power off. This is my dream. I can't believe that everything that's going along here seems to be in place with what I'm dreaming of, what I'm building here. And it's all tied to Ed's wheel. Because with Ed's wheel, he started with just turning the wheel, got the process going, and he has attachments. I'm telling you, Ed's got levitation attachments. He's got Corian attachments. He's got all kinds of things that just are included, but it all starts from the software. This is ancient software, we're going to call it. So now, listen. So we're back to this coil. Now I gotta activate the coil, find out to make sure that it doesn't deflect. Like for instance, let's go ahead and move the volts down a little bit. Okay, let's plug this back in. So right now we got it magnetized, okay? Oh, I gotta put the power on. There's our listen, it's simple. It's not complicated. Don't make this too complicated. This is like making a software. It left us the hardware is how I'm looking at it. And this is the software. This is part of it. There's also a controller device. That's a controller. And basically the controller will need electric to turn a commutator. Okay? And as a commutator turns, I got these low voltage 3-volt little electric motor. That's going to turn my commutator. And that's going to activate each section. Okay? Each section is going to be activated to the commutator. And then once you get it going 1/2 cycle, like a Wimshurst machine in a sense, that this is big time electromagnetic. Once you get the half cycle going, and then you'll be able to turn the power off. The power that comes from the center inductive pickup coils will be way more enough power so it's self stimulating. And then we're going to put a load on the center and we're going to push it and see how much load we can run with it, but one step at a time. So right now, let's go back and let's hit the lights off. It's getting a little bit darker. And let's just go back and maybe just check out the back EMF, because this is one part of this to show you that there's a lot of lost energy. Imagine if this was going in a pulsed frequency, especially to the coils. This is the whole other kicker, is that these coils all within 1% of a resonance when they're at their frequency. So their frequency right now is like I think it was at 2400 kilohertz. And I have to check to see what the inductive soft iron cores did to the frequency, because that slows down the frequency. So I have to check that out and see what I'm sitting at. But here you go, guys. That's what I can give you for right now. Stay tuned. I'm doing a lot of experimenting. Like this one was just showing inductive coils from the outside here. And we're showing that it's no connections, and we're popping off 3-volt light bulbs, 3, 6, 9, 12, 15, 18 volts of power is what inductively there is happening on the back EMF of this start of this process. There's all my coils. There's the wheel. So you guys leave your comments. I hope you appreciate the journey here. This is going to be interesting. I'm all over this. All over this. This is insane. Just to see, I don't know. This is just it's insane, because this is going to be just like this sine wave. And what we're going to do is treat the center as a longitudinal wave. Now, hear me out, guys. So the outside portions are going to be the ones that are bing, 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 bing. Bing, 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 bing. Bing, 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 bing is the outside ones. I'm only starting with the inside ones. Once I disconnect the power on the inside, this here becomes, because of the way this is being fired and because of its high and low oscillating that's going this way, guys, this becomes a longitudinal wave. Listen, the force of the energy and the direction of the energy is running simultaneously this way, okay? Simultaneously this way. So remember, outside is sine wave, inside is longitudinal wave. Guys, leave your comments. Hopefully you enjoy this. This is what we're working on. This is my crazy little setup here that we're starting. And then this is going to be my resistor. And then this is going to be our commutator brush and electric motor right here. And this is going to touch 2 segments at a time. So the first half cycle of these channels here are going to be charged, and this other back cycle is not going to be charged. So that'll put pressure on one side of the magnet. That's why they're individual, while the other side is under resistance. Now, if one side here is on pressure, think about this. Once I get the oscillation going, the goal here is to have one of these under direct power and the other one under resistance, in a different layout of resistance. So that sine wave that I'm creating on the outside, after the inside runs its cycle, the inside no longer powers. The outside cycle starts. So the back side of the cycle is going to be the low pressure side. So it'll be high pressure, low pressure. It'll be high pressure, low pressure. It'd be high pressure, low pressure. So sinal this way and sinal this way, guys. Hopefully I get this built before, like this week coming up, I got 3 kitchens to install. So I'm going to be a busy beaver. This weekend, I dove in this place and I took a day to wind these coils. Before I built these coils, I knew already how much resistance I wanted. I knew how many turns I needed to have. I knew exactly the voltage. I knew exactly the frequency. I knew exactly the inductance and exactly the capacitance that's created when you do charge it up. Important stuff to know. Fooling around days are over, is all I'm going to say. This is going to be the free energy device that everybody's going to have at their home. All right, guys. See, Vinny's all happy today. He's chewing on his bone. Vin, say hi to the people out on YouTube. Oh, watch it be back of a DeLorean. This is going to be hanging right there. That's a spot. Was going to put a big chalkboard up there. So, how many volts can it generate? Let's go here with the information. So, I got written down on these center coils, which are going to be the inductive coils, based on the microhenries that are going to be stored up in the iron core of these coils. Remember, these outside ones are going to be running like a frickin' machine. So we got those there are the 22 gauge. So I got my inductance, my energy inductance is going to be 0.729 microhenries. I don't know how to convert that into how much voltage, but I guess I'll learn as I work through the process on how many volts. It would be that times 7 based on just the way it's set up. Just the amount of wire, 1,000 turns on each one, the resistance of the outside wires with the resistance of the inside wires of this coil. And the setup is what dictates what the center coils are going to be able to put out. So I can tell you it's going to be 7 times 0.729 microhenries when it's in an inductive status. So we're not even getting close here yet, because guys, we're going to be working after we get this set up, and I got some more experimenting to do. We're going to be bringing in capacitance, and what we're going to be doing with capacitance here is we're going to be matching the capacitance that's built up in the inductive coils. Once these outside ones get rolling on their own with self-exciting, we're going to figure out through the numbers that I built on these the capacitance. Well, I got the capacitance here. So on the 24 gauge, our shunt capacitance is 6.756 picofarads. So what I want to do is 2 things. I was thinking about going old school and using something like this to match the capacitance in here. Remember, we're going to bring this thing in resonance. I believe once you bring it in resonance, we're able to amplitude the numbers I have here with all the coils and the turns and the inductance and the frequency. What that is just to get it to get in resonance. Once you get it in resonance, yes, it becomes a sonic. It's like a resonance becomes it's like this on top of the resonance. That area right there is what we're going to be jostulating. And also I want you to think about this. I didn't even mention it, but this is one of the main drivers for me, is that vibration. How'd you know that? How'd you even know I was going there? We are pinging this first coil, okay? When we ping the first coil, there will be a vibratorial vibration that goes downstream, okay? What did I just say? I said the effective shunt capacitance is 6.756 picofarads. So that means I can shunt down the end to match the frequency, to make this resonance, to match the resonance in this coil. This is phenomenal, guys. This is like taking all my 5 years of learning and all of a sudden, yeah, it's a tuning fork. You got that, Adam. So you got a ping, you got a down the road, you got a vibration, you got it vibrating back and forth. The system is running on the outside. Now, what we're talking about is these outside coils, guys, right? You guys get that? Yep. Well, I appreciate it. So you guys get that. So this pinging is these two outside coils once the inside coil starts the process. I just want you guys to understand that. You start the process. Then you're pinging. And once the outside pinging, they don't stop pinging. They just keep pinging. Keep it pinging. What does that mean? No moving parts. I see a patent and a patent right here. No moving parts. No moving parts. There's a lot of parts to this, though. Listen, the concept, from what I see, is already happening. But there's more parts to it to make it work. But once you get it tuned in and get it working, it's not going to want to stop. It's going to continuously, and no heat, nothing. No moving parts, nothing. The only moving part will be the commutator. What do you guys have to say about it? Something good to think on tonight? Did I give you guys some good food for thought? All right, we're rolling to 26 minutes. I think I overstayed my welcome. You guys have a great night. Hopefully, this to me is going to be, Leedskalnin was into something. I'm telling you, he was into something. This circuitry here, I think, is missing. There's parts up on his wall, but it's missing. I think the military came in and took this shit. All right, you guys. Peace out, my brothers. All I got to say is, to the man, there ain't no way you can make electricity with the lack of magnetism in these magnets. But Ed experimented with this damn wheel. I like that, though. This is the hardware. We're stuck with the hardware, and that's it. So, took a long time for somebody to come up with something in this ballpark. You did, Tom? You got your clover welded up? That a boy. Yep. Four like semicircles there, like crescent moons, and you got yourself the whole top there. I took this today. This was, when I first started this, like 5.5 years ago, I made this out of regular soft iron. Little did I know you can't magnetize soft iron, so I spent $1,400 on these little bars that I had, and now I just decided I'm going to bring them out. It's just soft iron. I want to do an experiment with this. Tell me what you guys think. In reading Magnetic Current, Ed talks about a steel. That steel balances up the magnets, and they get stuck there. So what I was thinking about doing was taking this and putting it inside my inductor heater. Okay, now follow me here. My inductor heater, just at the very ends. Get it red hot, then beat it down with a hammer, and start to harden the metal outside. So it becomes like hardened steel, basically. Keep hardening. Then you beat it down while it's red hot. And then tempering it, and then go ahead and quench it. Very important to quench it and stick it in cold water. And then you do it again and again. I wanted to do an experiment and see if I could turn this into a permanent magnet. Now this has nothing. This is just soft iron. Holy shit. Holy shit, look at this. It's got something on it. I don't know why. I was taking one of these coils. I spread this out just a little while ago. And I was taking one of these coils, and I was doing this, making a PMH with it. And I was using that as the coil to make the PMH. And I got it to stick. And it obviously put some type of magnetic memory in here. I bet it won't stay long. But it has no... It won't pick up anything. So, but anyway, so I wanted to check to see by hardening the soft iron like that, if we could magnetize it. So I'd put it up to the PMH and then tap it with a hammer and see if it's still there. Atta boy. All right, let me put down. Got me a little tripod. I love it. Smack it with the hammer. Let's see what kind of frequency this has. Now let's hear a frequency of a real magnet. This is a real Ford Model T V magnet. Might even say Ford on it. Nope, but let's see if there's any difference. Whoa, wait a minute. So obviously the metals in this magnet are different. You guys agree? You hear that? Still ringing. Now let's go ahead and let me get one that isn't angled like that. Maybe the angle has something to do with it. So here's another one. I didn't bend this one, so this is nothing. Let's go ahead and... Oh, that sounds a little better. But it's different metal than this. Different tone. You guys hear that? Still buzzing. And over here, this is just soft iron. Now remember, this has in it alnico. So it's got what in it? Nickel, right? It's got some copper in it. It's got soft iron in it. All right, let's get out of that stuff. But anyway, I wanted to do a test like that. When I get time, I'll figure that out. But for now, you guys see this. Hopefully you enjoy it. Food for thought for you guys for tonight. Yeah, it did sound like Close Encounters of the Third Kind. Peace out, my brothers. Oh, I also got one more thing. A little later on, I'm going to be putting some electrostatics to this. This is a piece of coral rock from Homestead, Florida. Very, 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 very similar to edge coral. Like exactly similar. Same everything. And I want to toy around. Very porous. That's right. Very porous. So this like section I put out with my finger. And then this becomes, it's almost like a bone. Like our bones. It's got porous areas and it's got like calcium. It's freaking calcium. Looks almost like a bone. But I already put powder of this in electrostatic test and they jump right up. So they're attracted. Okay. And I think that's where Ed did his levitation. But I believe that the electrostatic is not capable of yet, I guess, of lifting mass. So I believe mass comes from vibration, and that it would be sound. Okay, guys? So we're going to be getting into, once I get this system completed here, not stopping on this, is that sound will be doing the levitation, not static. But listen to me. The sound will be caused. I figured out how can we make sound. Well, how do we make sound now? Checking out your comments. That's right, David. But remember, with sound, we come into what? We're dealing with sound, we're going to be dealing with nodes. And then we're also going to be talking about, you're dealing with harmonics. Okay, I'm just saying, when you're dealing with sound, you're dealing with those attributes. And when I said earlier that Ed had other attachments and pieces to the wheel, they were different. And that's what I'm talking about, is the fact that through this vibration here, once I get this going, and if I can get this running, then pretty much from there, sound could be made, or this frequency could be matched to the Schumann resonance, which would be matching Earth's frequency. So I think there's something else that's coming along with this, is what I'm going to say. And the sound part is the levitation. Trust me, it's the levitation. It's the vibrations of the mass of the material that's all of a sudden, it's like flipping its poles. It's no longer being pulled down. Remember one thing, guys. What do magnets do? They all do what? What do magnets do? Leave your comments. What do magnets do? What do they constantly do? They constantly pull. Magnets constantly pull. They do show a sign of repelling, right? So there you go. So you got they're mostly pulling. So if you get them to repel, you'd have to do what? There's a principle of something you have to do in order to get repelling. And we see it in mass of a magnet up against another magnet is two masses. But space itself doesn't allow that. So if you look at Ed's place at Coral Castle, on top of his rock or wall around the whole place, he's got little clips up there. And I read from one of the testimonials that he had wire going across the whole top like zigzag above his wall. So what does that mean? That means everything in that cavity of between the wire and the ground in his whole compound had a chance to have electromagnetic induction. And if you look at his tripod as well reminds me of one of those lifters, to where you're putting a DC against the AC, a DC low voltage constant against a AC sine wave, and you're creating an electrostatic field. So that tripod had them capabilities. He did have chains up there to absorb the electrostatic, and that's what the chains would do, is absorb electrostatic. And he also has two cables coming down from the tripod, and he also has a running board around. It's the same as a lifter. If you see those lifters, it's pretty similar. A whole study there. But anyway, hope you guys enjoyed the video. Yeah, DC and AC. And even on Ed's, in his place right now, he's got a DC generator off a Model T Ford before they started making alternators. Who knows what he was doing with that? But he has like it attached to a piece of wood and something similar like this. And then it's got a notch. It's got the generator here. Then it's got a notch in it. So one thing I always thought about was that pipe. That's at Ed's place and my place. That pipe is a good way to produce a sound. Especially that it's attached to earth. that becomes like a chamber of a frequency by sound connected to earth, sticking up out of the ground like a frickin' like a battery pole. An easy way to create sound, old-timey experiments, especially in metal, is you heat up the bottom. If you torch that bottom right now, just for 2 minutes, I don't have my hand torch, but I'll do this experiment to show you. If I heat up the bottom of that pipe right there with a torch, we should be able to put our ear up here and hear it going, woo, to its resonant frequency of that pipe based on its length. We should be able to hear that pipe's frequency by the sound. And what is that? We're talking thermodynamics. So what if we were to have a coil down there at the bottom? Yeah, like an inductive heater. But we're dealing with we're dealing with a different setup. You could put a coil down bottom, heat up the pipe from the heat of the coil, and it would be a continuum like a bell ringing, okay? Basically, you heat the coil, you put electric to the coil in there, it heats up the pipe, it starts the resonance. The resonance now can oscillate, because I believe you had a coil going down the center. If you hit metal, it gets hot too. Shit. All these cores I had to cut, they were hot as heck cutting these things. Especially everything I made there. The center pieces of metal and the aluminum sleeves I used in here. Anyway, enough of rambling. Hope you guys enjoy, but that pipe, sound is involved with that pipe. DC is running next to the AC. The system itself, this itself, does not have enough power to do anything we're talking about. You have to go beyond what this wheel itself mechanically, in electromagnetic way, is capable of doing by coming up with software things like this that has been missing. You guys take care, man. Peace out, my brothers. Hopefully you enjoyed tonight. We didn't even get to the antenna. That's another part. We'll get to that later. Adios, amigos.